Let's work a stoichiometry problem where we go from grams of a substance to volume of a gas. Okay, now this is going to look completely different, but we really handle them just the same as we do any stoichiometry problem. Okay, so we're always going to write the given. Now, I notice that I have an unbalanced chemical equation. Okay, so first thing we have to do is balance. And let's see, I think I need to use a 2 there to get 4 nitrogen to make the oxygen work. So on the left side I have 2 times 5 or 10 oxygens, and then here I've got 4 times 2, 8, plus 2 more. So there you go. I'm going to use a coefficient of 1 right there for the oxygen. Okay, now that we have a balanced chemical equation, we can do all kinds of magical stoichiometry. So first thing we have to do is get to moles. Now, how do you know that you have to get to moles? Well, here's the trick. If you're going from one substance to a different substance, you'll need a mole ratio. Okay, so before I can use a mole ratio, I have to be in moles. So step 1 is get to moles. So in 205, I'm going to trade in grams for moles, and that would be the molar mass, and that is 108. Okay, now that step just converts to moles. Now, where am I going? I'm going from moles of N2O5. I always write the units first. Did you notice that? Because I know that whatever unit I have, I want to cancel it out by some ratio. Okay, so I've got moles of N2O5. I want to get rid of those, so I put that opposite. So when I multiply, those units will cancel. And I'm going to, this time, moles of oxygen. Why? Because that was what the question was asking for. Now, what numbers go in there? This is the fun part. All you have to do is grab the coefficients. So in front of the oxygen, I've got a 1. And in front of the, N2O5, I have a 2. Okay, now, so at this point, if I stopped and multiplied, that unit would cancel, and I'm left with moles of O2. Now, is that where we're going? No, not moles, not grams. We're going to volume of oxygen at STP. So here is the ratio that we know. Any gas at STP, standard temperature and pressure, has a volume of 22.4 liters. Have you used that ratio before? That's a nifty little trick. If you don't know that one, you could use the ideal gas law. That would get you there. Okay, so moles of oxygen are going to cancel, and then we go to the calculator. 25 divided by 108 divided by 2 times 22.4 gives us 2.6 liters of oxygen. There you go. So the secret is we used 3 things actually. We used a molar mass, we used the mole ratio, and that's the stoichiometry part. And where does that come from? The balanced chemical reaction. And then we used the molar volume of a gas at STP. I hope that helps. You can do chemistry.